Lesson 2, Unit 4. Here we go. Chapter 4, whatever we're calling this. We're going to be talking about angles of triangles. We're going to get a few theorems, and we're going to do a few examples, and then we're going to be done. So let's start with the triangle angle sum theorem. This is a theorem that we have actually talked about before. We talked about it in the last lesson. This is something that you've known about for a long time. Actually, we're just gonna make it official, which is good because we can use it to prove things and all of those things. So the triangle angle sum theorem says that the sum of the interior angles of a triangle equal 180 degrees. So if we were to label that with this triangle here in mind, what that would say is that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. Now, for point of clarification, it's good, as we continue to look at these look at proofs and look at things, it's important to note that so you would not say that these are supplementary, because when things are supplementary, we're talking about two angles. So in a linear pair, this one and this one would be supplementary, right? This is not supplementary, although they do end up equaling ultimately the same thing. This is the triangle angle sum theorem, which says that all of them added up, all the interior angles add up and equal 180. Let's look at an example using this theorem. Whoops. I don't know why that happens sometimes. So we're going to find the measures of each numbered angle. So we've got a bunch of numbered angles here. So we're looking at several different things. We're looking for this one right here. We're looking for this one, this one, this one, this one, and this one. So what is going on here? Well, we've got two angles that are congruent, and then we've got some vertical angles, and we've got some other stuff. So the best way to tackle these is to hit them sort of one at a time, right? And to kind of take them a little bit as we go. So let's see if we can look through and find ones that we can find out. Are there any triangles? Now there's a bunch of triangles too, right? There's this little triangle, this little triangle, this little triangle, and this big triangle, this big triangle. So it's important to kind of see where all the puzzle pieces are, right? So are there any triangles when we take a look at this where we know all but one, right? Because then we could use the triangle angle sum theorem. Well, yeah, this one right here. So we can find this angle 7 using that. So the measure of angle 7 plus 58 plus 65 would equal 180, right? Now we can just solve that little equation. We can combine like terms. So 58 plus 65 is... So you probably want to sanity check that with some math. You could do it in your head. You get 110 plus, so what is that? 13, so 123. Right? You could do that in your head, right? And then we can sanity check, make sure, like we always try to do. So 58 plus 65. Now, you might be thinking, 123, sanity check worked. You might be thinking, why do you keep using different calculators? Well, because I like to show you different things on there and different calculators and different things, because you may not have the same calculator I do. So I like to throw in different ones when I can and whatever I feel like on a particular video. Equals 180. So we're going to subtract that 123 minus 1, 2, 3, minus 1, 2, 3. So the measure of angle 7 equals 180 minus 123. Do that in your head, subtract 3, and you get 77 minus 120. I don't know, 50 something, whatever. 180 minus 123. I don't know. I got distracted. Whoop. This calculator seems like it's a little slow on here. 180 minus 123. And this one I'm only using a trial on 50 something. 57. Is that what I was thinking? Yeah, I was going to get there eventually. 57. So that measure of angle 7 is 57 degrees. So that's one of them. So we need to find the rest of them. Now, do you see any that you can find really, really easily? Well, I do. I see this vertical angles right here. Since I've got vertical angles, what are vertical angles? They are congruent. So the measure of angle 5 equals 57 degrees. Nice. Nice. All right, so let's take a look and see what we want. So we've got this. I'm going to kind of label some of these. So this is 57. This is 57. So what else could I find? Well, I could find angle 6 because that's 7 and 6 are linear pairs. So are 5 and 6, right? If you were asked to prove a theorem or something, that might be a good way to get there on this particular picture. So that means 180 minus 57 is angle 6. Now we've already got, if we just kind of rewind back into this problem, that's how we got this 57 number was by subtracting it from 180. So we can just kind of rewind the tape and figure out that measure of angle 6 is 123 degrees, right? There we go. So we just kind of rewound back up to here, right? So that's that one. Now, the measures of angle 8 and 9. So we can get those because those are equal. So there you go. So we've got the measure of angle 8 times 2, because it's the same, these two here, plus 123 equals 180. Sorry, I didn't really mean to put that units there. We don't usually put units in equations because it gets confusing, right? So 2 times the measure of it. Now, why did I do that, right? That's because that these two are equal. Their measures are equal. They are congruent, right? And so that's why I can do 2 times one of them plus this one equals 180. So we're going to get there again. We're going to subtract 123. Oops. Equals 180. We already know, we already did that math. That's already 57. So 2 times the measure of, angle 8 equals, what am I writing? Sorry, y'all. I don't know where my brain is. Somewhere else. Minus 1, 2, 3. Measure, 2 times the measure of angle 8 equals 57. We already did that. Now we've got to divide and get rid of that 2. So we're going to divide 2 on both sides. So the measure of angle 8 equals 57 divided by 2. Let's pump that in the calculator. It's going to be 20 some odd, right? 57 divided by 2 equals 28.5. 28.5 degrees. So that also equals the measure of angle 9, because those are congruent. All right, let's do this one last puzzle piece. This one last puzzle piece is angle 4. So we're going to use that theorem again. Let's see if we can move this over. I wrote that real gigantically. You move over here, get out the way so we have more room. So 67 plus 57 plus the measure of angle 4 equals 180. 67 plus 57 be 110 plus 14, 124. Let's sanity check that, right? Good idea. So 67 plus 57 equals 124. Plus the measure of angle 4 equals 180. Subtract off that 124. Minus 124. Minus 124. So the measure of angle 4 equals 56, right? Let's double check, sanity check that. 180 minus 124 equals 56. There we go. We got them all. Easy peasy lemon squeezy. Let's hit the next thing. Boom. Exterior angle theorem. The exterior angle theorem. It's easier to write this one just in pictures and in words. So what it says is that if we have an exterior angle, it is equal to the sum of the opposite two angles. So writing that in with this example, that would say that the measure of angle 1 equals the measure of angle A plus the measure of angle B. And that would be true in any space. So like if we extended this angle out, I know that's not straight, but this one right here would be equal to the sum of these two that are opposite it, right? So that's going to be true all over the place. Oh, I forgot to turn my notification sounds off. Take a half second to do that so we're not interrupted by another time. There we go. Okay, so that's what it says. Let's use it in a problem to kind of put some meat on it. All right, so jumping into a problem. So here's our picture. We want to find the measure of angle JKL. So we're looking for the measure of this angle right here, JKL. So that's this one. So that's 2x minus 15, right? So we've got an exterior angle here, right? So that would say that this angle equals the sum of these two. So let's write that in math. So this angle is 2x minus 15. So 2x minus 15 equals the sum of these two. So x plus 50. Now we're solving a little equation. It's easy peasy. We've got long lost friends. We got to get them together, right? So we're going to subtract x from both sides, minus x minus x. 2x minus x is 1x, which is the same as just x, right? Bring down what we haven't touched, minus 15, and bring down 50. This 15 is subtracted, so to get rid of it, we will add it. Plus 15. So x equals 65. Now, be tempting to just go done, but we're not done because we're not asked for what is the measure of x. We're asked for the measure of JKL. The measure of JKL is 2x minus 15. So the measure of JKL equals 2. Whoop, what am I writing? X minus 15. Well, we just found out what x is, so we can take and substitute that in right there for x, right? So 2 times 65 minus 15. 2 times 65 is 130, right? Does that sound right? Let's take a look at it. Do a sanity check. 2 times 65 equals 130. Sanity check fulfilled. One of these times I'm gonna do the mental math wrong, and y'all are all gonna get to laugh at me. It's okay. Probably wouldn't even cry if we were in person. So that means 130 minus 15. So therefore, the measure of angle JK. What am I writing? KL equals 115 degrees. One more set of theorems and one more example, and then we are going to be through. So, triangle angle sum corollaries. I honestly can't remember whether we've seen corollaries before. Corollaries are where we have a theorem, and because of that theorem, it lets us say these theorems, right? And so it's corollaries are still theorems, right? So they need to be proven. They do have proofs, all of those things, but they go with another theorem. So these are two theorems, two corollaries that go with the triangle angle sum theorem that we learned at the beginning of this lesson. So the first one is the acute angles of a right triangle are complementary. So with this picture example, that would tell us, what does complementary mean? They add up to, their measures add up to 90 degrees. So in this one, it would say that the measure of angle A plus the measure of angle B equals 90 degrees. That's what complementary means, right? So that tells us that. And this one, there's less to write here. It just says there can be at most one right or obtuse angle. And that's true because if you have an angle that's 90, you need two other angles that are less than 90 to make up the rest of the triangle, or else it won't be a triangle. Or if they're greater than 90, we have to have two that are less than 90 to make a triangle. And so that's what we're talking about. So if we have an acute angle like angle L, then these two have got to be acute, right? So let's take a look at one more example, and then we shall be through. So we're supposed to find the measures of each numbered angle. We got a lot of things going on. We've got three numbered angles up here. We've got angle 1, 2, 3, and 4. So what can we do? Well, let's take a look and see what kind of puzzle pieces. It's problems like this that really, I mean, there's a lot of reasons why I like geometry, but it's problems like this that make me really, really like geometry, because it's just kind of a puzzle. You take a look and like, okay, what do I know? What can I find out? Well, I can take a look here and realize that this triangle is this triangle is a right triangle right here. Whoops. This one right here, right? And so since this is a right triangle, there's the right angle. That means that these two angles are complementary. So that means that the measure of angle 2 plus 38 equals 90, right? Now, you could use the full triangle angle sum theorem and do 38 plus the measure of angle 2 plus 90 equals 180. So you could use the entire thing, but because we have this corollary, we can make this even simpler equation, because we know that these two have to be complementary, which is really, really great, right? It makes our life easier. We like things that make our life easier. I do. I hope y'all do as well. So this guy's really easy to solve. We just have to subtract 38 on both sides. Minus 38 minus 38. So that means that the measure of angle 2 equals 52 degrees. Blap. Wow, look, 52 degrees. This one's also, look, that one's also a right triangle, which means that we can just say that the measure of angle 1 is 38 degrees. We just rewind the tape because it's got to be the same. Since this one's 52 degrees, that means that one's 38 degrees. Rewind the tape. There it is. Easy peasy. No big deal. Oh, wow. Look at that. Angle 3 and angle 2 are both complementary to each other. So that means that this one is the other end, which means that the measure of angle 3 is 38 degrees because 2 and 3 are complementary. Wow. Oh, wow. Look at that. Angle 1 and angle 4, because we know these three here. Well, okay. So angle 4 is maybe a little bit. Well, no, just kidding. I was going to say angle 4 is a little bit trickier, but because of the way it's all laid out here, we know that this angle right here is a 90-degree angle, because these two are 90. If this one's a 90-degree angle, then that one is, because they're a linear pair. Wow. So that means we already know this one, which means that these two are complementary to each other. If that one's a 90-degree angle, we love these corollaries. We can do this without we only did one little thing. We just subtracted by 38, and then we have all of the answers to this problem. Wow. Measure of angle 4 is 52 degrees because it's complementary to angle 3. Blam. Isn't that nice? Corollaries are handy. Honestly, right angles are handy. If you see, and there's a lot of shortcuts regarding right angles. We're going to see that again later as well. So if you see right angles in a triangle or almost anything, it leads to all these nice little shortcuts, which makes our life easier. So right angles make our life happy. That's it for this lesson. If you're in my class, I will see you in class. Do your homework, all of those things. If you're not one of my students, thanks for joining us. Excuse me. Thanks for joining us. Let us know how else we can help you with math or science or homeschooling in general. Y'all have a wonderful day. Bye-bye.